Some circuit boards arrived today. It's the fourth version of the Splishmeister Disco-Shart, and this is the truly international version. It will work in 120 volt countries and 230, or should I say 220 to 240 volt countries. And this, to facilitate the lower voltage, I've divided the circuit down the middle. It is so symmetrical, it is really symmetrical to the point of being ridiculous. And it has basically a capacitive drop on either side. So it's got the drop capacitor with its own discharge resistors. It's got an inrush limiting resistor. It's got a full bridge rectifier based on discrete 1N4007 diodes, a smooth capacitor, a couple of series resistors, and then 32 LEDs on this side, and then the same replicating on the other sides as a sort of mirror image. Let's start building it. So for this I'm going to use this frame. For those wondering why it's called the Splishmeister Disco-Shart, it's because it's designed to go into an existing cheapo disco light. And once in that disco light, it then gives it a new lease of life as a non-flashy, flickery thing that you can actually customize to a degree and make it into a sort of interesting architecturally type light. I'm just going to zoom down here. So the first thing I'm going to put in is the smaller components. I'm going to start off here with the 470k resistors that are used to discharge all the capacitors. I'll try and get it into the right holes here. Good start, Clive. Let's bend the leads so it doesn't fit in. I preformed all these resistor leads. I'll even put them in the correct direction according to the color code in the text. So these are the discharge resistors. Each is rated 470k, and a typical quarter watt resistor has a voltage rating of 250 volts DC. So it does make sense to use two in series to spread the voltage, because each one will then have about half the voltage across it. In this case of this one up here, the voltage will be capped by the LEDs, which will be around about 100 volts. And if you're wondering about that not leaving much headroom on 120 volts, keep in mind that it's 120 volts full wave rectified, calculator, 120 volts, 120 volts full wave rectified and smoothed, so that's times 1.41 equals a peak of 170 volts. That's a good margin. That also means that these capacitors, because there's two of them, they can be lower value. The next components I'm putting in are going to be more resistors. These are 330 ohm resistors. I've put two in series to make up 660 ohms and put them in series with the LEDs just because it helps with limiting peak current from the capacitor when LEDs sometimes blip and short out briefly, as happens with some LEDs. It means it's not going to pass a huge current spike through the string of LEDs. It's also going to reduce the ripple very slightly, although there shouldn't be much ripple because it's got smoothing capacitors. The value of 330 ohm was just a arbitrary value I chose that kind of fitted. The next thing I'm going to put in is the 1N4007 diodes. The 007 bit meaning they're rated for 1000 volts. They're not quite being used anywhere near that. So let's get these into the holes. The holes for these are slightly bigger. Incidentally, if this is a success, this is the printed circuit board file that will go up as a Gerber file on the website, so you guys can have some of these made if you wish yourself, because it's no point shipping stuff from the circuit boards in the UK anymore. I used to do stuff like this in my shop. It's just not possible. The cost of postage is really just made it unviable. That's partly down to the Royal Mail being sold to the government by itself so it could cash in on e-commerce. That might be a bit of conspiracy theory going on there. But also the fact that America, sick of getting all the parcels in from China, decided to put a levy on every single package coming into the country. And that has impacted us quite significantly because for China's extra dollar, for some reason, it's like double that for us. So I think the Royal Mail has creamed off a percentage off that as well. Okay, that is those in. I could put these resistors in too. They're not going to be that much bigger. I think the foam will accommodate that. These 10 ohm resistors, they're metal foam resistors. They're just like inrush limiters and potentially fuses if all else goes wrong, if there's a huge apocalypse. That could happen if something went short circuit, but it's unlikely. It's most likely to happen if this capacitor down here went short circuit. That's possible. Now I'm going to put the cover on this frame. And this is where you see it says ISEL Germany, but I don't actually know if it is made by ISEL or not. I think that's the closest I could find was ISEL. If it is, then that'd be quite good to know, because they're still about and they're still potentially making the frames. Oh, that's very dark. Let's brighten it up. Brighter. Oh, that's nice. Okay, solder. I shall start soldering these. And I've spaced this circuit board out to be quite nice to solder. So I'm going to solder one lead of every component first, as I usually do, because that way afterwards I can make sure they're positioned correctly once I've soldered them. And if they need aligned, it's easier just to remelt one solder joint than it is to remelt them all. So I've got another resistor here, another one here, and here. Fairly straightforward to solder. It is actually quite a nice, well laid out circuit board. I've chosen for the holes, mostly for the smaller components, about 0.8, including the LEDs, 0.8mm hole. For the diodes, I've chosen, and the capacitors, I've chosen 1mm holes. I think for the, no, actually capacitors might not be, they might be 0.8. I think the diodes might have the biggest holes, because they tend to have thicker leads, because they're rectifier diodes. They're rated sort of about 1 amp, so they're designed with a sort of decent lead. You can get the 1 amp diodes with thinner leads, but it's not necessarily a great idea. Right, okay, I'm going to flip this over. It's going to flare out. I'm going to tame it down. There we go. This is where I tip it upside down and realise that I hadn't soldered all the components and then they pour out, but it doesn't happen that often. Older and wiser. Okay, that looks pretty good. This is where it would actually have been advantageous not to put the bigger resistors in, because they are just that bit deeper now. It could potentially not hold the other components in snug enough to place it down, but they are all pretty much locked in position, so it doesn't really matter. Ramble, 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 waffle, waffle, waffle. So I want to solder those two. The next thing after this is the next component to go on is the LEDs, and that's where it's going to take quite a while, so I'll probably pause while I'm doing it. I'm not really sure what type of LEDs I'm going to use yet. I've got a couple of options. I can go for a fixed colour, and I was thinking maybe golden warm white, so you get basically an 8x8 array of golden warm white pixels pointing at the wall. Or, and this is probably got the edge at the moment, I was thinking of using RGB slow LEDs, but with a clear lens then, so it projects the colour changing dots, but it will almost certainly project them as a triad of red, green and blue. It won't actually do it as a pre-mixed dots. It doesn't work that way with those LEDs, because the chips are going to be shining through a lens, and it will literally focus an image of the chips on the wall. And the chips, because they're just a group together, will focus through the front lens LED onto the main lens of the light as 3 separate dots. But we'll see what it looks like. I don't really know what it's going to look like. This is looking good so far. I shall crop these leads, then put the thing back in, and then make tough decisions about LED colours. So I'm going to crop these leads down in length. So far, so good. That feels nice to build. It is a through hole, it's not surface mount, which has also got an advantage, but you can't really use the surface mount LEDs in this application, because they have to have the lens in front of them for the best effect. You also can't use diffused LEDs. I have tried making one of these with the diffused colour changing LEDs, and because it relies on most of the light being fired forward through the lens of the light, it doesn't work so well. It's very diffused. You can see the effect in a dark room, and it looks quite nice, but it's not bright at all. You could possibly cheat that up by pushing a bit more current through, as they do in the original disco light, but that's not something I really like doing. Okay, so let's get these leads out the way. Dump them there. Take a sip of... it's a gin and tonic, but made with rum, just because that's what I had. Rum and tonic. Okay, right. I think this can go back in the assembly frame now. Click. Right, I'm going to go with these ones. I'm going to go with the red, green, blue, slow. So while I'm going to copy all these leads, it's going to take a wee while. I can't really think of much to say while I'm doing that. So I shall pause momentarily and I shall be back in a jiffy. The LEDs are cropped. Let's get these in. So why is it called Splooshmeister Disco-Shart 4? Well, silly name, but the reason it's the fourth version is basically it just splooshes light out the front, that's why. The first version was just for 240 volt. It wasn't really suitable for American use because the combined voltage of all the LEDs was about 200 volts, and that meant that they couldn't be used on 120 volt with a standard capacitive dropper. It just wouldn't have made them light much, if at all. The second version had a design error in it, I'm afraid to say. It was the Mark II version. It used one capacitive dropper, and then it used a range of links and resistors. And the idea was by putting them in a split combination, you could make it, you could run the LEDs in either series or in two parallel groups. And I screwed up. Fortunately, somebody spotted it. I only had one small batch of 5 test circuit boards made. They have an error, but it doesn't really matter because just cutting one track, if you use it at 120 volts, it's fine. But if you use it in 240, because of a rogue track, the bottom half won't light until you cut a track and then it enables them. It just, it all seemed a bit too simple when I designed it, as sometimes happens. Disco-Shart 3. Disco-Shart 3 is still in the computer. It never made it to completion because it was based on this. But I decided to start from scratch because nothing was quite looking right the other way, and I thought, let's just start from zero, just for the outline and the LEDs in the middle. And so it just skipped straight to Disco-Shart 4, and this is Disco-Shart 4 with its dual arrangement. It's quite nice, very symmetrical, quite a pleasing circuit board. It was actually quite nice to design as well. So, right, there's plenty of LEDs to put in yet, so what I'm going to do is I'm going to pause momentarily while I put these LEDs in, and I shall see you shortly when I start soldering them. That's all the LEDs in. Now, just to save you the torture of watching me solder all these LEDs, I'm going to time-lapse it. So let's switch to the time-lapse now. Okay, more practice needed with using time-lapse because 3 seconds for the entire process was just a little bit too quick. I'm not sure if I'll even include that video clip in because I recorded that live time-lapse on open camera. And when you do that, the video format seems to be slightly different. Because when you try and join it in with other sections on VidTrim Pro, which is what I use for splicing a lot of my videos, it wants to reprocess it from scratch in some way, and it takes ages. See what happens. I'll maybe do it. Maybe I'll put the time-lapse in, which is just excruciatingly fast. It's just like whizzy. Maybe I solder at that speed for real. Not really. Actually, you know what? Let me put this capacitor in the right way around. I have bent the leads the wrong way in this one. Tell you what, before I put this capacitor in and have a kaboom, I'm going to change this for another one because I don't want to bend the leads over the other way. I'm forgetting that this is genuinely a symmetrical circuit board with positive on the outside. I bent both leads the same way. One moment, please. That's better. Incidentally, these, because I've run out of my usual UK supplier sourced high voltage electrolytics, I'm using generic Chinesey ones, which I should never have bought from eBay because it's bad enough that they're Chong-X capacitors. The fact they came from a generic seller called Home Improvements or something like that suggests they maybe reject high voltage capacitors, and that's never going to end well with electrolytics. Things worthy of note. The discharge resistor for that electrolytic is right at the end, right under the electrolytic, so I may just nudge that up off that a little tiny bit just in case it gets warm, but to be honest it's not going to see an awful lot of heat because the voltage will be capped by the LEDs across this capacitor and therefore that discharge resistor. Now, I could have used class X2 capacitors for the limiters, but I thought let's go full Chinese and I'll use suntan 470 nano, 400 volt. So for the capacitors, I actually commoned a load of pads here so that it can accommodate a wide range of sizes. So this actually just happens to fit in the smallest pad spacing. Let's solder them one at a time. I shall just gently support them and solder one lead first and then the other. And I won't force them in because I don't want to stress the leads. I'm so considerate. Not stressing the leads, the little capacitors. So that one looks relatively well lined up. I'll probably regret saying that when I turn it over and find it isn't. Is it? It's looking okay. I shall angle it down the way very slightly, just for cosmetic appearance. Okay, in goes the next capacitor. And that will be the circuit ready to be hooked up to 240 volts. Or 250 volts as it seems to be recently. The local supply, it's been quite spicy. I'm guessing it's because nobody's really got any heating on. Because it's been pretty warm around here recently. Warm and stormy. Sunny during the day, absolutely blitzing storms at night, as happens. This is what happens when you live in the middle of the Irish Sea. Crop these. 2 more solder connections on this, but that's it. Just to moisten the solder pads for the connection points. Live and neutral. Live going through the capacitor, neutral going straight to the LEDs, but to be honest, it doesn't really matter which way around to go because it's AC, but by live going through the capacitors, actually, technically speaking, live at the bottom would be going through the fusible resistors. It doesn't really matter. It's fine. So, quick check of LED alignment. If the LEDs are all perfectly aligned, they should look more or less symmetrical. If they're not aligned, you'll get strange visual effects, like the one down there is giving a strange visual effect. It is not aligned. There we go. I've spotted one. And both the connections have been soldered, so I shall melt both at once and square it up. Is that any better? Yes, it is. That looks better. Okay, now it's time to get the light up and put this into it. So I'll just grab that light. I'm not sure where it is. I shall go and get it. So one moment, please. The disco light has been found. Let us whip the cover off it. So for those unfamiliar with this project and its various reincarnations, this is a generic, what you might call a moonflower. This is the point it would be doing quite good to show you what an original moonflower looked like inside. But this is a modern LED equivalent, and it's very, very simple. Let's see which side the circuit board is connected to. The circuit board is connected to that side. All the more simpler for my modification to tame it down. So here is one of the original circuit boards with the matrix of LEDs, but just one capacitive dropper, which was perfectly feasible. This is a prototype. This is the first one. That's nice, with little extras on the back. That was to stop me getting little nips off it when it was holding a charge. Let us desolder the live and neutral and smack them straight onto the new circuit board. Is this wise? Yes, it is. So here is live, which can just go straight across that way. How is this going to go? It doesn't really matter how it goes. I shall put it on that way round. So live goes on there. And neutral goes on at the bottom. Here we go. Trying to hold that wire in while holding the circuit board and reflowing the solder. That looks like it. Now what will happen when I plug this in? Will it go kaboom? There's always a certain element of excitement when you're testing a prototype. So this circuit board is quite nice. The idea is that these LEDs each effect have a lens on them. And there's a big lens in front. It's a glass lens. This is where people shout at me because I touched the surface of the glass lens and therefore left greasy fingerprints on it. I don't think it really matters. We're not talking class here. The focused output from this, you can adjust it in these slots backwards and forwards, then gets fired through the lens and it creates an image on the wall of the LEDs. What is going to happen here? Is it going to work? It's looking pretty good. Let's keep my fingers away from all the live bits. The LEDs are morphing and changing colours. That's also pretty good. I'm just going to point at the wall and go, oh yes, that looks pretty damn good, I have to say. Oh, you're going to like this. Let me turn this light off, take the exposure off, and try and show you what this is going to look like. No, I'm going to have to box it all up. And then I'm going to have to point at a wall and show you what this looks like, because so far, and excuse me just pausing momentarily while I just point at the wall, that looks pretty good, I have to say. That's not bad at all. The LEDs, because I'll turn the light back on, because the position of the LEDs behind the lenses is different to what it could be, the circuit board could actually have done with being just aimed slightly differently. I'll show you what I mean. I shall show you what this looks like when it's pointed at a wall. Okay, let's see if we can catch this, what it actually looks like. Now, interestingly, when you look at it, depending on the distance you are from it, it does focus on the individual LED chips. You've got the distinct red, green and blue dots. But they're also skewed very slightly to the side because they're not centered onto the lens. So it produces an interesting aura effect around it. And there's 4 positions you can mount it inside. In the very foremost front position, it defocuses the colours enough that they overlap slightly, and it does produce a slightly better colour mix. But having said that, this isn't too bad, is it? And it is very bright. It's a good visual effect. I measured the power at round about 5 watts, and the power factor is about 0.4. It would be better in America, the power factor, because of the lower voltage drop, but it's still plenty bright. You know, it really is visually a good bright effect. In fact, just the dust alone, I can actually see it sparkling through the air. It would be nice with a bit of fog in the air to actually see how that looked, which is an interesting idea. Maybe fog would be an interesting idea for this. I shall give that a go. But there we go. It's an interesting visual effect. It certainly works. If I'd used the standard centered LEDs, it would have produced more symmetrical dots. But with the red, green, blue off to the sides, it creates a completely different effect, but one with basically 3 times as many dots and lots of different colours. So it's a pretty good effect. I do like it. Oh yes, now that is quite a lot of beams of light. So technically speaking, that's 64 LEDs with 3 beams each that just fade in and out. So that's a lot. That's about 180 or so beams of light. That's pretty good. Let's get some vape into it for a little burst of intensity down there. Yeah, that is a nice visual effect. Lots and lots of bright beams. It's pretty impressive for just 5 watts. It's producing a good effect. That would actually stand up quite well just as a sort of ambient effect in a sort of nightclub scenario. That's very good. I like that. It's worked out well.